Grade 12 Physics, Fields Note number 5, Millikans experiment. By the end of the 1800s, there's two fundamental questions in particle physics. The first one was, is there a fundamental particle that has a fundamental charge? And the second question was, if there is that particle, what is that charge? So Robert Millikan at the University of Chicago went ahead and did an experiment to try and figure out if there was electrons, what would be the charge on an electron. So he designed this experiment where he basically had a barrel with two chambers. The top chamber had an atomizer full of oil on the side. And an atomizer is like a perfume spray bottle. He would spray oil into that top compartment. The oil would rub against the air particles and become statically charged. Some of it would collect and drip through that middle plate into the bottom section. So when it reached the bottom section, there were two charged plates, one above and one below. That oil drop would fall at a terminal velocity, which you could measure through that eyepiece, but then he would put a charge on those plates and reverse the direction of that particle based on its charge, make it go up and down, up and down. From making it go up and down from terminal velocity, he could measure its mass and measure the total charge on that oil drop. So what he did after he did this with a whole bunch of oil drops, Millikan took some data and wrote down the total charge on each of these oil drops, but not knowing how many individual electrons were on each of these oil drops. So what we're going to do here, we're going to do a bit of a thought experiment to figure out or look at the method that Millikan used to find the individual charge of an electron. Let's say we had 5 oil drops with the following charges. The first oil drop will have 15 coulombs. The next one will be 24 coulombs. The third one will be 39 coulombs. The next one will be 12 coulombs. And the final one will be 21 coulombs. So pretending that this is our selection of data, what would be the elementary charge in this case? How many electrons would have to fit on each of these oil drops to get those charges? Basically what we're asking ourselves is, what is the smallest common multiple we can fit onto each of these oil drops? But by examining 15, 24, 39, 12, and 21, we would say here the lowest common multiple would be 3. So here we would conclude that the charge of an electron would be 3. That means 5 would fit on the first one, 8 on the second one, 13 electrons on the third one, 4 on the fourth one, and then 7 on the fifth one. So that's basically what Millikan did to find the charge of an electron. When he was looking at those oil particles moving up and down in his apparatus, he could calculate what the total charge on each of them was based on the voltage across those plates. Knowing that the particle, when it was rising, it was going at a terminal velocity. Here, a terminal velocity means forces are balanced. So gravity pointing down must equal the electric field force pointing up. So we can set those equal, where the electric field force comes from the field intensity, which is force divided by charge. If we put those values in, and also knowing here that the electric field intensity between two plates is equal to V divided by D, when we rearrange the equation for charge, we get mgd divided by voltage, where Q is charge in coulombs, m is mass of that particle in kilograms, g is acceleration due to gravity, d is the plate separation distance in meters, and v is the voltage on those plates in volts. If we check the units on this, the left side, which is charge, so that would be coulombs. The right side, once we put in all of our values here, all the units for our values, we should put acceleration due to gravity, not meters per second squared, but newtons per kilogram. That will help us simplify some of it. We can see the kilograms go. We simplify it here. We have to remember that work equals FD, right? So a Newton meter divided by a joule, that comes from work equals FD. So finally, Millikan, for an electron, found that lowest common multiple, and he concluded that a charge on an electron is negative 1.602 times 10 to the negative 19 coulombs.